Hello everyone, welcome back to my channel. So today we are going to tackle one of the most challenging linked list problems on LeetCode, right? So this is rated as a hard problem, but honestly, by the end of this video, you will not only know how to solve it, you will understand every single line of code we write and why we need them, right? So we are going to solve this problem step by step, and it will help you solve, help you understand how you would solve in real coding interview, right? So let's break it down. What the problem is actually trying to do or asking us to do, right? So we have a linked list, right? let me just scroll to the example. We have this linked list, right? We need to reverse this nodes in group of k. So we have k equals 2 and we have the head, this whole node as 1, 2, 3, 4, 5. So the aim is to reverse them, right? We need to reverse this, right? So that this 2 becomes 2, 1, right? The end will be 2, 1 in group of k. So k is equal to 2. Since k equals 2, we are only having 2 groups. So we also have 3, 4, which will be swapped as 4, 3. The last value remains the same because it is not in group of k. It's less than k. All right, this value is less than k. So looking at the third example, we also have similar questions, same values, right? We have 1, 2, 3, 4, 5, right? But this time around in group of k, which is 3. So the first 3 nodes becomes our k group, and so on and so forth. So 1, 2, 3, and then the rest are not part of, which is 4 and 5. It's not part of the k. Right, it's not in group. So if you were to have 6, then you would have another group of k where we can also reverse them, right? So that is how it is. So first, I have my own approach, a personal approach. This is how I approach this problem when I saw it. First, you need to ask yourself, how do we check if we have nodes left, like this, right? This 5 here. How do we know if we have them left? And how do we reverse exactly k nodes and stop? Last, you need to ask yourself, how do we link everything together so that the list doesn't break? So first, my step is I count ahead, right? I count ahead looking at this example. Before reversing anything, count k nodes ahead. And if you can't count k, then we are done. If you can't count k nodes, we are done. And the next thing is to reverse the group. You use the standard linked list approach or the technique, but only for k nodes, and connect the pieces together, right? That is where the tricky, that is where the trick comes in, right? That is the tricky part. After reversing a group, you need to connect it to the previous group and prepare for the next group. That is how it basically works, right? Then we repeat the same process. We keep on moving to the next group and do it all over again, right? Okay, so the challenge is keeping track of all the connection points. So already LeetCode has given us, and we are also, remember that we are also doing this in O of 1 complexity or space memory or memory space, right? So I'll come back to that, right? So LeetCode has given us this list node class, right? So we have 2 variables, or basically 2 2 pointers, right? So that is the value and the next. This is a pointer. Yes, so we need to start building our solution from it, right? So first, what I'm going to do is to create a dummy node that points to the head, right? So I'll just create a dummy node that's that points to the that points to our head, right? Points to the head, right? So that's it. So 0 and this becomes our head, right? So we are creating, why are we creating this dummy node in the first place? When we reverse the very first group, the head of our list is going to change, right? So for example, we reverse this group, that is 1 and 2. The head, right, of this list is going to change. So for example, with k is equal to 2, or in this example, after reversing the first group, node 2, this value 2 here, becomes the new head, not node 1, right? So this dynamic node acts as a stable starting point, right? That never moves. So it is like a fence post that we can always reference, right? This makes our code very clean. That's how we need them. So we don't have to treat the first loop as a special case, right? Okay, so what we need to do is to we need a pointer that will always point to the node before the current group, right? So therefore we need a group next this or previous group. No, we need a previous group rather, right? So we pass or we assign the dummy to it. So that means after we reverse a group, we need to connect the previous part of the list to our newly reversed group. So that is why the group or the previous group keeps track of where the connection point is. Do you get it? So it's like remembering where the last train car is, like splitting a train, right? So it's like you want to remember the last part so that we can attach the next one. Then we write our main loop. Why do we need an infinite loop? We need a while loop. A while loop is an infinite loop. We need we need a while loop because we don't know in advance how many groups we will have. So we will keep processing groups until we run out of nodes, like we did here. Until we run out of nodes. So until we run out, we are not going to stop. That is why we need a while loop. So we will keep processing groups until we run out of nodes. Then we break it, right? So inside of this loop, I'll check if we have k nodes ahead. So if self dot get kth method, I will explain this kth method, right? So first thing is the previous group and the k value, right? So we need group ref and k, right? And then we check if we don't have k nodes, then we are done. That's where we break the loop, right? So if not kth, then break out of the loop. So what is kth doing here? This get kth, what is it doing here? Well, we will do this later, right? We will need it, we will write it in a moment. So I'll just put, let me just define it before, then I just copy. I will just cut it. So when we get there, I'll just paste it, right? So we need to find the kth node from our current position. Okay, so if it returns none, it means we don't have k nodes left. So we should stop processing and break out of the loop, right? So the helper method here, or this get kth, is the reason is that we need to pick ahead and see if k nodes exist before we start reversing it. We need to check if these nodes exist before we can start reversing it, like we have done below, right? So that is it. So for example, let's just write the helper method, right? So the FAANG get kth, right? This is actually our main function. So you work on it, like, I mean, it's just a main function. I just want to explain some few things. We need 3 parameters in this. Then the next thing is to move k steps forward from the current node, right? So while the current and the k is greater than 0, right, then the current node equals the next current, right? So just call this sonnet next. Then we subtract 1 from k. So k equals k minus 1, or you can just write k minus equals 1. It's the same thing. Then we return the current. Node. So let me just explain this in simple terms, line by line, right? So this loop here, right, means we are going to take steps forward, right? We are taking steps forward. We keep looking while 2 conditions are met or true. That is, this condition and this condition, right? the k greater than 0 and this condition. This is also a condition, right? So this current here is not none, right? It's not none. We haven't fallen off the end of the list. And then the k greater than 0 means we still have more steps to take. So this current is equal to current dot next means move on to the next node. This is like taking one step ahead or one step forward, and then we decrease our step counter by 1, right? We just took one step so that we can have one fewer step to take. That is it. And then we return whatever code or whatever node we ended up at. If you successfully took k steps, this will be the kth node. If you run out of nodes, we hit none, we hit nothing, so we will return none. So for example, if you have 1 2 3 4 5 in this example, we start at dummy, which points to 1, right? Which points to 1. The step 1, the first step is to move to node 1, right? The first node. So in this case, we have k is equal to 2, but k becomes 1, right? The next step is to move to 2. So k becomes 0 because k is equal to k minus 1, where k is 2 minus 1, which is 1 minus 1, which is 0. And now that k is 0, we just stop and return node 2. That is it, right? And another example, if we have 4 and 5, this 4 and 5 here, we call this method the helper method. That is the getKth, right? So in these parameters, we have in this function parameter, we are going to have the node 3 as our first parameter in it and k at 2. So we start at node 3, right? We start at node 3, then we move on to the node 4. Okay, so now k becomes 1, right? K becomes 1 in this case. Then we move to node 5, k becomes 0. So wait, this current dot next here becomes none because there is no the loop exists and return none, right? It returns none. That is how it works. So back to our main function, we've confirmed that we have k nodes, so that so now we need to save the important pointers, right? So I'll just copy this somewhere, right? So we'll be using this later, right? So we need to save. We need to save the node that comes after the group. Okay, we need to save the node that comes after the group. So so the previous so the next group, right? Group next becomes the kth next, right? The next thing is to reverse the current group. Okay, we need to reverse the current group. That is the next step. So yes, I think we need an actual reversal loop, right? So we are definitely going to write another loop. So say while the current group is not equal to the next group, right? That's the group next. Then since we are saving, we need a temporary variable to hold that, right? But wait, after we reverse our group, we need to check where it connects to, right? That is the group next. So the group next becomes our first node, so that first node of the next group. So that is it. Remember that. So before the reversal part, after saving this is what we are just saving this, right? We are just saving the node that comes after our first group, right? So after reverse our group, we need to know where to connect it to. That is the group next. So the group next is the first node to the next group, right? To the next group. So that's why we need that is where the reversal part comes in. So before that, let's reverse the current group. Then the previous group will point to the node after our group, right? So something like group next, or the next group, and then the current starts at the first node of our group, right? So current is go to group underscore previous dot next, something like this, right? Then we set up our reversal. So I've already written this. So in standard linked list reversal, previous status none, but here we want the last node of our reverse group to point to the next group, right? That is it, the next group. So we initialize the previous group to the next group, right? Okay, so this current group dot next blah 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 here is the first node of the group you want to reverse. So the previous group is the node before our group, right? I mean the next group. So the next group, right, this group here is the first node of our group, right? So the actual, we need to reverse exactly the k nodes, right? So you just need a temporary variable to store the current, the current next node or whatever. Yes, the current next, right? So assign this to, what am I writing next? Current previous, and then our current becomes our previous, right? So we assign current to previous. So previous equals the current, and the one we stored in the temporary variable becomes our current node, right? So TMP, right? So this is the classic linked list reversal pattern. This is how it works. So we keep this loop keep reversing until the current reaches the next, right? Why? Because the next group is the first node that is not in our group. Once we reach it, we've reversed all k nodes and we should stop it, right? We need to stop it. And then this temporary variable means before we change any pointers, we need to say where we are going next. So this temporary variable is just like it's just storing its temporary, right? Yes, it's just a bookmark. So it's like we will come back for it later, right? Good, right? And this line means this why we are assigning a previous value to the current to the current next group is where the reversal happens. We make the current node point backward instead of forwarding it. Instead of pointing it to the next node, it now points to the previous node, right? Then we move the previous forward to the current node so that the current node will be the previous node for the next iteration, right? And then we move to the next node, right? Using our, this is just a container of storage. So it's like when we are reversing 1 and 2, this is how the reversal is done. When you are reversing 1 and 2, where group or the next group is 3 or the next group node is 3, the starting point for this previous one becomes 3 and the current is 1, okay, right? I think in the example 2, yes. So the temporary variable or the temp or our storage or our bucket becomes 2, right? Then it's like you've written 1.next, right? So 1.next, right, which is 3, and now points to 3, these 3 here, so that the 1 becomes the previous value, okay, so that the 1 becomes the previous value and the current value becomes 2. That is how it works. So the next thing is since temporary, we've stored this 3 in the temporary variable. Since we've stored this in the temporary variable, if we move on to the 2, which is 2.next, it becomes 1 and now points to now 2 points to the 1, right? 2 points to the 1. So the previous now becomes 2 and the current value becomes 3. So current group will be the next group, which is 3 equals 3. Is that same 3? So we stop. So we've swapped it. So it's like 2, 1, 3, like we have in our example. We have in our example 1, right? 2, 1. So 2 to 1, then 3. We swap it. That's how it works. So after the reversal, we need to connect everything. We need to connect the what I mean is we need to connect the reverse group to the rest of the list, and then this temp saves the original first node, now the latest node, which is the latest node, right? So what we need to do is right. So before the reversal, this next group pointed to the first node of our group. After the reversal, the node is now the last node of our reversed group. So we are saving it in the temp because we will need it later, right? So temp right, so temp group previous dot next, right? Okay, so what is happening here is now what we need to do next is to connect the previous part to the new head of the reversed group. Yeah, so group or the previous group, let's go to the cave. Yes, so after reversal, cave, which is the last node, is now the first node of our reverse group. We need to connect the previous part of the list to this new first node. So we make the previous group, right? We make the previous group point to K, right? Then we move previous group to the end of the current group. That means we are just going to prepare for the next group, right? So that is it. So preparing for the next group is like group or the previous group equals temp tmp. Why do we have to update the previous group? Remember that the previous group always points to the node before the current group. So we just finished processing one group. We need to move to the previous group to the end of the group. I mean this group, which is temp, right? That's the original first node. So to prepare for the next iteration, right? And finally, we return a new head of the list. So return dummy.next. That's it. Why return dummy.next? Remember, our dummy node is at the very beginning, right? So it's been pointing to the actual head of our list. That this whole time it's been pointing it to the actual head of our list. Even if the head changed, which it did, if you reverse the first group, then the dummy text always the next dummy head, all right, always becomes or points to the correct head. That is how it works. So I think we are done solving this problem. Yes. So I think, oh shit, so I need to just shift this. Yeah, because in connecting this to the next node, I think it should be outside of this. It should be inside of this line, I mean this loop, and then this comes this way. Yeah, so I think we are done solving this problem. And that main function we wrote, we need to call it, right? We need to call the main function. Just copied it, just pasted it. Shift, yes. So that is all. That's the whole problem. So right now we need to test with the test values LeetCode has given us to see if everything is alright. We have an error. It says global name list is not defined. Okay, so let's look for where the problem is. Because so that is list node, right? List node. Because we already have it on top. But it's commented. Yes. So looking at the test examples, wrong answer. You need to check it out. Alright, so this is the output of our code. Right, so the case 1 says if the head is 1, 2, 3 and case equal to our output had 1, 3, 5 instead of 2, 1. So we need to check it. right? Okay, so I think everything is alright, but we need to go through the codes very well. Okay, so let's check this part where we connected the reverse group to the rest of the list. That is where the problem is coming from, because looking at the case 2, 1, 2, 3, 4, 5, where key is equal to 3, we are not supposed to get 1, 4, 5. We are supposed to get 3, 2, 1. Yes, but even though we had the first, even though we have the, because of the carrying group, right? But even checking the example 1, case 2, case 1, 2, 3, 4, 5, we need to check, we need to reverse this, right? 1, 2, so it becomes 2, 1, 4, 3, and 5. But we are not getting that in our test result. We had this result, so we need to check. So we need to check where we connected the reverse group to the rest of the list. Right? And this part, I think this is where we started connecting it, right? Okay, so do you see the problem? We are doing next group with Keith, right? But this is just reassigning our previous group variable. It doesn't actually connect anything in the linked list. Do you get it? So we are just moving a pointer around in memory. We are just moving the pointer around in memory. We are not changing any next pointer in our actual list. So what we need to do is to just pass the next pointer to it, right? Dot next, just this. Yes, because I think you see the difference now. You see the difference. Yes, so we need to actually modify the list. We are taking the next the previous group point to and changing its next pointer to point to the key value or the key, right? So if we remove this dot next, it's like telling the code that it should look at the key instead. It doesn't change the list. You get it? But if you add this next group to it, I mean the next previous group, or the next to it, it means make group or the previous group point to cave. That is actually going to change the structure. So this is just a super common mistake here. It's just a mistake with linked list, confusing variable assignment with pointer manipulation. So you have to ask yourself that, am I changing a variable or am I changing the list structure, right? So that is the correct code. So let's just run our code one more time, right? I think this time should work. Yes, accepted. It was accepted. So like you can see in the case 1, where k is equal to 2, we have 2, 1, 4, 3, 5, right? And that was expected. And then we check the example 2, where k is equal to 3. So that is it. So let me talk about the time complexity, which is O of 1, right? Sorry, the O of n is rather the time of complexity, right? So think about how many times we visit each node. That is the time complexity. The get cave method, this method, visits each node once as we scan through the list, right? Then the reverser visits each node once as we reverse it. And even though we have a while loop inside, another while loop, right? I'm talking about this one. We have a while loop, and this is the main loop, and this is the inner loop, right? Each node is processed a constant number of times. So the total time complexity O of n, where n is the total number of nodes, that is it. So n is the total number of nodes, and the space complexity is the O of 1, right? That is the beauty of this solution, because we use constant extra spaces, like these few pointers, dummy, previous group, right? This one, this pointer, previous group, current, previous, and temporary, the cave, and the next group, right? So there's no recursion, no call stack, no arrays or additional data structures, right? From the look of the code, right? Or no arrays or additional data structures. We just use pointers. That is what we mean by space complexity of 1, right? And there we have it. We have conquered this LeetCode problem, right? Problem number 25, one of the toughest linked list problem out there? Yeah, maybe. To me, it's simple. Yes. So let's just recap. You need a dummy node, right, to create a stable reference point and simplifies edge cases, right? And then you count before you reverse the node. You count these nodes before you reverse them, right? Always verify that you have k nodes before doing any reversal. And pointer management is very important, right? Pointer management is very important. Always save the next group before reversing it. Then you connect carefully after it, right? Connect carefully after. And the classic linked list reversal, but that is the reversal pattern. That is classic linked reversal. But with the stopping condition, we need to break it, right? We need to stop it. This problem really tests whether you understand linked lists at a deep level or low, I mean shallow, right? How deeper you understand it. So if you found any part confusing, that's completely normal. Yes. Yeah, if you found any part overwhelming, it's normal. Go back and rewatch those sections. Try coding it yourself without looking at the code. Yes, that's how we really internalize it. So if this video helped you understand the problem better, please give us a thumbs up and subscribe for more LeetCode solutions. Drop any questions in the comment section. I read every single one. Until next, happy coding. Thank you for watching.